today we will study about the carbon and compounds. Okay. So carbon and compounds, very important chapter. Okay. See, carbon and its compounds, that is carbon combining with the different elements, they form the carbon compounds. So we are trying to study that itself separately, right? Because carbon they can combine, okay, with they will form so many different compounds. Okay, they form so many different compounds because of its special properties. So that so many compounds we have. That's why we study it under the separately. So in the chemistry we study like organic chemistry, right? We study the organic chemistry separately. That means what is organic chemistry? It is about the carbon and its compounds. That is compounds which contains the carbon. Okay, studying about we call it as the organic chemistry. Okay, so we will study that separately. Why? Because so many different compounds are formed using the carbon because of its special properties. Okay, and carbon valency is 4. It is a tetravalent in liquid. Carbon valency is 4. It is tetravalent in nature. You people also can hear me, right? So they are tetravalent in nature. That means their valency is 4. Okay. So they form the covalent bond. They form the covalent bond. So why the covalent bond? Covalent bond means sharing of the electrons. So because of that, they form a bond. Sharing of the electrons. Because of that, they form the bond. That bond, they call it as the covalent bond. And the compounds formed by that, they call it as covalent bond. Again, I repeat, see, we have two types of bond. One is the ionic bond, the other one is the covalent bond. Ionic bond means one will be giving, the other will be taking. Oh, come here. One will be giving the electron, 1 or 2 electrons, the other will be taking 1 or 2 electrons like that. So that is the ionic bond. Giving and taking is the ionic bond. But covalent bond is sharing of the electrons. That means the electron will be revolving around both the atoms. Okay, the electron will be revolving around both the atoms. That we call it as sharing of the electrons. Okay, so carbon forms the sharing of the electrons, so they form the covalent bonds. So, what is the reason it forms the covalent bonds? Why not the ionic bonds?
Sharing.
Why why it should share? Why it can't give or take?
Because it needs
See, when we have the octet rule, correct? We have the octet rule. Okay, so according to the octet rule, it has 8 electrons. Okay, 8 electrons should be present in the outermost orbit. See, whenever it has 8 electrons in the outermost orbit, it becomes stable in nature. So that like all the elements, they try to make 8 electrons in the outermost orbit. So carbon in the outermost orbit has 4 electrons. Carbon in its outermost orbit has 4 electrons. So it has to either take 4 or give all the 4. So that orbit is not there. The another orbit, inside orbit, it will be filled. Correct now? So either to give 4 or take 4, it needs a lot of energy. So that is why they share the electrons. That is why they share the electrons. Okay, clear now? So for example, we have methane, one compound, that is CH4 is there. Okay, so carbon, it has 4 electrons in the outermost orbit. I will write like this, or I will write like this. It has 4 electrons in its outermost orbit. That 4 I will write here. Okay, after a long time I'm seeing you. Sit here on this. Sit here, man. If I ask the question, if you people are not answering, see what I will do. I'm not joking. Everyone, you people also should sit silently. Okay. See, carbon, it has 4 electrons in the outermost orbit. So they form CH4 means what? Hydrogen, how much electrons will be there? 1 electron. So the it is like this. That means this hydrogen, it has 1 electron, it shares with this carbon. So this electron will revolve around the carbon as well as the hydrogen. Okay. And this electron of carbon, it revolves around this carbon as well as this hydrogen. This electron revolves around the carbon as well as this second hydrogen. And this electron will revolve around this carbon as well as the hydrogen. And here, the carbon third electron, it revolves around this third hydrogen and this carbon. It will not revolve around these, only with this hydrogen. Okay, this with this as well as this carbon, like that. Okay, understood now. So this electron of hydrogen revolve around hydrogen as well as carbon, and this electron of carbon will revolve around carbon as well as hydrogen. So altogether, for the carbon, how many electrons are there? 2, 4, 6, 8. For the hydrogen, 2 here. For this hydrogen, 2, 2, 2. First orbit. So total, it will be the octet rule is satisfied. Correct now. So that is why it is like that. So it is sharing of the electrons, not the giving or taking of the electrons. So carbon will form covalent bond. So the compound formed by carbon will be covalent compound. Okay, covalent compound. So what and all we studied now? Carbon and compounds we are studying separately because it forms bonds with the so many compounds. It forms so many compounds. That's why we are studying it separately. That we part of the chemistry, we call it as organic chemistry. Okay. So carbon is a tetravalent in nature. It is tetravalent in nature. Tetravalent means valency is 4. Valency is 4. That's why it is tetravalent in nature. So the valency is 4. Either giving 4 or taking 4, it is difficult. To form the ionic bond, either it should give 4 or take 4. It is difficult. That is why it forms the covalent bond. That's why it forms the covalent bond. And covalent bond, okay, the compounds formed by covalent bond, we call it as covalent compounds. We call it as covalent compounds. So an example I told CH4, it is called as the methane. So one carbon, it has a 4 electrons in outermost orbit. So it shares with a 4 hydrogen atoms. Okay. So that understood. Now, once you understand, it's easier to group the things. So 4 outermost electrons are there. So this hydrogen has, each hydrogen has 1 electron. So this hydrogen shares the electron with this carbon. So this electron will revolve around the hydrogen as well as the carbon, like that. Okay. So on this, with this carbon and hydrogen, this electron with carbon and hydrogen, and this electron with hydrogen and carbon, and this with this carbon as well as hydrogen. This electron with carbon and this hydrogen. This electron with carbon and hydrogen, this hydrogen, and this electron of carbon, it rotates around this carbon as well as this hydrogen, like that. Okay. So that's how it is formed. Covalent bond, it is not as strong as ionic bond. Okay, so melting point and the boiling point of the compounds will be less. covalent compounds will be there, right? So there the melting point and boiling point of those compounds will be less when compared to iodine. Written. Write down. So a molecule of hydrogen. See, always when in a reaction we write H2 only, right? We always write H2. That means what? Always hydrogen will be in the form of a molecule. That is two hydrogens combining by the covalent bond. They form the H2 molecule. Always it will be like that only. That's why in a reaction also we write it as H2, right? So they form a single covalent bond. They form a single covalent bond. Okay. One covalent bond means one pair of electrons, if it is sharing, we call it as a single covalent bond. That is, hydrogen, we know it has one electron, correct? Hydrogen has one electron. So both the two hydrogen atoms, if you take, each one has one atom. If they share, that is, see, one hydrogen atom is there, one hydrogen atom is there. This hydrogen has one electron, and the second hydrogen atom has one electron. So, this electron will revolve around this hydrogen as well as this. And this second here, the in the second hydrogen atom has also one electron. So, this electron will revolve around this hydrogen atom as well as this. So altogether, both has two electrons. Altogether, it both has the two electrons. So since it is revolving around the both, that is why it is called sharing of the electrons. So if one pair of electrons, see, if it is one pair of electron is shared between the two, then that we call it as single bond, single covalent bond. Okay, single covalent bond. So we write like this. Here means for this hydrogen, these are the two electrons which is revolving. Okay. And for this hydrogen, these are the two electrons which is revolving around this. That is the meaning. Okay. And bond, how you write? One covalent bond between the two. One covalent bond between the two. So this we call it as the single covalent bond. Okay. So this is a single covalent bond. Write down this. See, whole organic chemistry, it is from this chapter only, starting from this chapter. Even in 11th and 12th, it is everything it's about this only. It keeps on going. Okay. So if you understand very clearly these things, actually it is very easy. It's not so difficult to remember the things. So in the oxygen, what is the valency of oxygen? 2. So in the outermost orbit, how many electrons are there? 6 are there. So total 8, 2 comma 6. Total 8 electrons, 2 comma 6. So in the outermost orbit, 6 are there. Valency will be 8 minus 6, 2. That means it is ready to take 2 electrons. Okay, like that. Then, so 2 oxygen atoms, how they form? So 2 oxygen atoms. In the oxygen atom, in the outermost orbit, it has 6 electrons. 2, 4, 6. Okay. So this with the another oxygen, 2, 4, 6. 6. Each has 6 electrons. So they form So, see, this electron of the first one shares, it revolves around the first oxygen and as well as the second. Similarly, this electron of the second oxygen revolves around this as well as this. So it has got now the 7 each, right? And here the second electron of this first oxygen, it revolves around the first one as well as second one. And the second electron of the second oxygen element, it revolves around the first oxygen as well as the second. So these four, so two pairs will revolve around the both. So total, it will have 8 electrons. Okay. So for the first oxygen, how you will write? For the first one, these are the 8 electrons which will be revolving. So 2, 4, 6, 8. For the second electron, these are the these are the 8 electrons. 2, 4, 6, 8 will be revolving. Okay. And here, two pairs of electrons are shared between the same two, correct? Two pairs are shared here. Here, earlier hydrogen, only one pair was shared. Here, two pairs are shared. So this we call it as double bond. Okay, this we call it as a double bond, double covalent bond. Okay. Right. This is double bond between the two oxygen atoms. So this we call it as double covalent bond. Double covalent bond. And how do you write this? Like this. Two lines will represent. Okay. This is the second example. Third one, it is about the triple bond. Triple bond between triple bond between two nitrogen atoms. Between two nitrogen atoms. Triple bond between two nitrogen atoms. Write on this. Nitrogen valency is 3. Okay. Nitrogen valency is 3. So for this first nitrogen, 3, 2, 5, 6, 7, 8. These are the 8 electrons which is revolving around this nitrogen. For the second nitrogen, right, right, I'm telling you. No. Written. So nitrogen has valency 3. Okay. So here these 3 electrons is shared between the first one and the second one. And these 3 electrons are also shared between the first one and second one. That is 3 pairs. Between the same two, only 3 pairs are shared. So this is called as a triple bond. Triple covalent bond. Triple covalent bond.
Which is stronger, ionic or
Ionic is stronger than covalent. Ionics, it's sharing, right? It is more strong. And one thing, no, it's about the nature of that. We can't say why means since it is sharing, it is more stronger. That's it. Okay. Hmm? Just directly gives and takes an electron. No? That's why it's stronger. So, ionic is more stronger when compared to covalent. That is why the see how we will come to know about that means by boiling point and the melting point. See how the boiling point and melting point will change. See, you are giving some energy because of that it will break. If the bond is more stronger, it requires more energy. That means more melting point, more melting point, like that. So, since ionic bonds they have more boiling and melting point, they are more stronger. From that, we will be able to compare. Okay. And in single, double, and triple, which is stronger? Stable. Stable is actually single bond is more stable. It's its nature. Okay.
how's the nature? When it takes the reach to for something is said. In three of this going to be chain, it's not right. How's that stronger than people?
That's what how you will know means by the different combination what you will get. Because of that, you will be able to know. See, for example, um, there is saturated fats, you would have heard, unsaturated, you would have heard. No? Saturated means what? It is single bond. Unsaturated means double or triple bond. So, saturated, it is difficult to dissolve. Whereas unsaturated it is easy to break. That is why even in say for example hydrogenation of oil, they say dalda is formed. You would have heard, no? Dalda is formed. Dalda is it will not digest it. 1 minute, wait. And then dalda it is difficult to digest. Whereas the you have oil, it is easier to digest when you compare with that. Dalda, it is saturated fat, that is single bond they will have. Okay, so whenever it is single bond, it is difficult to digest also because it is stable in nature. What is the reason? Is it's stable in nature, whereas this is unstable in nature. That's it.
How do you make it stable in having the bond?
Yeah. It is not like that. Whether which is easy to break, it depends on that. Okay, that means which is required less energy to break, like that. It depends on that. Okay, right. This is the written. Okay. So what we are writing this now, this we call it as electron dot structure. We call it as the electron dot structure. In exam, sometimes they ask to write the for any compound the electron dot structure like that. Okay. So done. Written. Huh. Write down electron dot structure. Tomorrow we'll study about allotropes. Today we'll write about electron dot structure. Electron dot structure for methane. Electron dot structure for the methane. Huh. So methane means CH4. Okay. So first we will write the molecular formula. This is a molecular formula. Or anyway, wait, we'll write such. This we call it as molecular formula. Okay. Next we'll write structural formula. Structural formula means how the bonding is. Each bond means carbon is sharing one electron with hydrogen. Hydrogen is also sharing its one. That means one electron pair. One electron pair it is sharing. So it forms one covalent bond. Okay. What doubt? See, carbon, it's one electron sharing with this one. If I just naming, don't write in exam. Just for your convenience, once I'll write. This, if I mark it as 1, 2, 3, 4. Okay. So, one electron is sharing with this. Another electron, this hydrogen, one hydrogen atom is sharing one electron with this. So, one electron pair it is sharing. So, it forms one bond. Like that. Okay. So the structure you are writing, it is called structural formula. Now the electron dot structure. Electron dot structure. So carbon has 4 outermost electrons like this. Okay. Hydrogen, see, you can write cross or dot. Okay, anything you can write. Usually what we will do for one cross, one dot, for hydrogen I'm writing dot so that you will know. Easier to identify, that's all. But both cross, both dot also you can write. It is the same thing. It's fine. Okay. So for this hydrogen, these are the 2 electrons which is revolving around it. So for this hydrogen, these are the 2 electrons which is revolving around it. For this hydrogen, these are the 2 electrons which is revolving around it. For this hydrogen, these are the 2 electrons which is revolving around it. Okay, for the carbon, 2, 4, 8. See, 2, 4, 6, 8. 8 electrons for this carbon. So this structure we call it as electron dot structure. So this is the name methane. This is the molecular formula. How many molecules are there? Structural formula. This is electron dot structure. Then write for ethane. What is the molecular formula? C2. It's 6. Like that structure. See, first thing, it has all single bonds. Okay. Carbon, see how to write C here. See, for this carbon, 4 bonds. For this carbon also 4 bonds. For hydrogen, 1. So 2 carbon, 6 hydrogen. We'll get C2H6. Write electron dot structure for this. Everyone, I'll come and check. Okay, write for this third one. Then we'll write for once double bond. Propane. C3H8. Structural formula. And once writing the structural formula, I will tell first thing. Here we have only single bonds. Okay, only single bond. That means each one sharing only one pair of electron is shared between the 2 elements. Single bond means one pair of electron shared between 2 elements. Okay, so 3 carbon atom we have. Carbon has 4 bonds. So remaining fill with the hydrogen. One is bonded with carbon. So remaining fill with the hydrogen. How many carbon is there? 3. How many hydrogen is there? 8. Okay, understood. See, carbon 3 is there. So write 3 carbon and 4 bonds for each. So remaining, whatever the remaining bonds open are there, write hydrogen for that. Now write structural formula for this, everyone. For this one carbon, two carbon, one C here. See, three carbon is there here. For this carbon, we have four outermost electrons. For this also, we have four. Or we write little here. One minute. For this carbon, we have four electrons. For this carbon, we have four electrons. For this carbon, we have four electrons. Okay. And we have hydrogen here. It has one electron. Hydrogen here, one electron. Hydrogen, one. We have one hydrogen here, one electron. One hydrogen here, one electron. One hydrogen, one electron. One hydrogen, one electron. One hydrogen, one. Okay. Now grouping. For this hydrogen, we have two electrons. 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 You have two electrons. You have two electrons here. Two electrons for this hydrogen. Okay. And now for this carbon, we have how many electrons are involving? Two, these two, three, 2, 4, 6, and these two electrons. Okay. For this carbon, we have 2, 4, 6, 8. Okay. Huh? When you are putting this, no, Netra, you had circled even this carbon that you should not circle. For this carbon, we have 2, 4, these two electrons plus this. So we have 2, 4, 6, 8 electrons. So this is electron dot structure. Okay. So tomorrow we will study about the allotropes of the carbon.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.